Hello guys, welcome to my channel. So in this video we are going to learn about volatile and atomic variables. So why do we basically need the volatile keyword? So first we will understand why do we need the volatile keyword. So you all know that in the first video I have told that all the threads share the same memory, okay? But internally each thread will have its own CPU cache for better performance. So imagine I'll give you an example. You can see in the main memory we have a counter variable and the value of the counter is 10, and there are two threads, so thread A and thread B. Okay, everyone has its own cache. So imagine if thread A changes that counter to 20, okay, then if thread A changes the counter to 20, then thread B will still read the old value from its cache, that is counter is equal to 10. So this is known as visibility problem. Visibility means thread B will not see the updated value. So we can solve this problem with the help of volatile keyword. So what is volatile keyword? Means volatile is a keyword that ensures that every thread reads the latest value from the memory. So I will give you one simple program. Like we will write like class counter volatile int count is equal to 0. So whenever the value of the count changes, all the threads immediately see the latest value. Okay, that is what volatile do. And also this is the most important interview point. So volatile keyword, it guarantees visibility, not atomicity. So atomicity means the execution, like every transaction should execute completely or it does not execute at all, that is atomicity. So this volatile keyword ensures visibility but not atomicity. And there is another example. So we have a volatile boolean running is equal to true is there. So while loop, so if it since the running is true, it keep on executing. Or if another thread can stop it by setting the running is equal to false. Okay. If without volatile, what happens is this old thread, that is the first thread, will not see the updated value and keep on running and doing the work. So that is how like we can use the volatile keyword to make sure that all the threads see the latest value from the memory. Why volatile isn't enough? So I'll give you an example. While volatile keyword isn't enough, so there is one operation like count plus plus. You can see this is only one operation, but it has three operations. One is it will read the count value and it will increment the count and it will write the count. So there are three operations that are happening in count plus plus. So imagine there are two threads executing this count plus plus together. So thread A reads value 5, thread B also reads value 5, and both these threads they will increment to 6, and both these threads will write 6. But actually the expected is 7 because count plus plus means count is equal to count plus 1. Thread A increases the count by plus 1, thread B increases the count by plus 1. That means initial value is 5, so plus 1 means it should be 7, but the expected expected output should be 7, but actual output is 6. So this is called as race condition, and volatile cannot prevent this. So I think you understood why, because when two threads are executing together, so they will not see the updated value. So that's why this happens, and volatile keyword cannot prevent this. Then we go, in order to achieve this or solve this, we go to some concept known as atomic variables. Java provides these atomic variables in a package called as java.util.concurrent package, concurrent.atomic package. There are some operations such as atomic integer. Atomic integer counter is equal to new atomic integer. And if you want to like count the value, then there is a method called as counter dot increment and get. Like if you want to increment and get the value, like there is a method called as increment and get. And the beauty of this method is there is no synchronization required for this method, and there is no log concept required for this method, and this is thread safe. I'll give you some of the atomic classes like atomic integer, atomic long, atomic boolean, and atomic reference. These are some of the common atomic classes. And how does this atomic integer work? Okay, atomic integer, how it will work means it will use the concept of cache. Cache means compare and set. I will explain what is cache. So we will see now we will see the difference between volatile, synchronized, and atomic integer. So when it comes to visibility, so yeah, volatile guarantees visibility, and synchronized also guarantees visibility, and atomic integer guarantees visibility. When it comes to atomicity, so volatile does not guarantee atomicity, and other two things guarantee atomicity. And when it comes to lock, only synchronized method will use the lock, and other two does not use the lock. And when it comes to performance, synchronized block, since it is synchronized, the performance is lower, and other volatile and atomic integer is higher. So best for if you want to change the status flux, you will use volatile, and synchronized for complex shared operations, and for counters and atomic numeric updates, we will go for this atomic integer. So now I'll explain when to use what. When you should go use volatile. So when you should use volatile means whenever you want to stop the flags, whenever you want to set the configuration values or status variables, then you can go for volatile. So volatile boolean shutdown is equal to false. So volatile ensures visibility, not atomicity. And when to use this atomic integer means whenever you want to do counters, visitor count, sequence numbers, and retry count, then you should go for atomic integer. Why use atomic integer means why we are using atomic integer in order to perform this counters means atomic operations such as this increment, decrement, and everything we can do without using synchronized block, and it ensures that the performance is faster. That's why we are using atomic integer. And I told you, right, atomic integer uses a technique called as cas. Cas means compare and set. So what it will do means it will update the value only if it hasn't changed since it was last read. That means it will update the value only if it has not changed since its last read. That's the technique that atomic integer is using. And I think we will have a quick revision. So what we have learned, we have learned about volatile, which solves the visibility problems. That is, it will make sure that all the threads read the latest value from the memory. And volatile does not make the operations atomic. We also see with that count plus plus operation. And atomic integer provides thread safe numeric operations. We have seen that one as well, using atomic integer counter is equal to new atomic integer. And cas is the technique which is behind this atomic integer. And you should use atomic integer for counters instead of synchronized whenever appropriate, because the performance is higher. So I think we have come to the end of this video. I think you have understood what is the difference between volatile, what it guarantees, and also you understood about the atomic variables and the atomic operations. If you have any questions or any doubts, please write it down in the comment section, and thank you so much for watching.